evaluate each expression. These would come up on a non-calculator part of your test. So, looking at this right now, evaluate, that means we should be able to get a single number in the end. I mean, if you were allowed to use your calculator, you would just type this in exactly as you see it, which is 3 log base 9 of 6. And then it is minus log base 9 of 72. And surprisingly, it's a nice number in the end, 0.5. So we have to be able to come up with that 0.5 without our calculator. And looking at it originally, when we look at part A, okay, log solve for an exponent. Is this easy to do? 9 to what exponent is 6? Is 6 on our chart for powers of 9? No. Are 6 and 9 on the same powers chart anywhere? No. That's not easy to do. Next one, log 9 of 72. Well, I know 9 squared is 81, so it's probably going to be 1.8, 1.7, but I'm just guessing. How do we do this without our calculator? Well, one of the things we have are our log laws. We have an expanded form here. We should check maybe if I write it as a single log, I might be able to simplify it. So first of all, I can put that 3 in as an exponent, and then subtracting is the same as dividing. Now this is non-calculator, so I'm going to give you some strategies or some hints for simplifying fractions. I would not change the 6 cubed to 216. You can if you want, but I wouldn't do that. In fact, I would leave the 6 cubed because it means 6 times 6 times 6 divided by 72 is 2 times 36, which is 2 times 6 times 6. That simplifies things pretty easily if I break up the numbers. Rather than multiplying them out and trying to simplify, if we write them as their factors, sometimes they have the same factor on the top and the bottom, and you can simplify your fraction. What would we be left with? 6 over 2. What does 6 over 2 simplify? To 3. Now, remember, logs solve for exponents. So at this point, when we have log 9 of 3, we're now asking ourselves, 9 to what power would be 3? So that's changing to exponential form in my head. Now, some of you are going to be able to figure that out in your head. Because what is a half as a power? It's a square root, right? Square root of 9 is 3. So some of you are going to be able to do equals 1/2, next step, done. Some of you, you're going to say, yeah, I wouldn't have saw that, Mr. JR. That's not me. Okay? So if you don't see that, well, how did we solve these before? We said let x equals log 9 of 3. Change it. The base is 9. Exponent is x equals 3. Are 9 and 3 ever on your same powers chart? Yes. 9 is 3 squared. So you could change 9 to 3 squared. This would be 3 to the 1. So we get 3 to the 2x equals 3 to the 1. Part where we go, so 2x has to equal 1, and x has to equal 1/2. More work, obviously. Wonderful if you can see the answer right away, if you know your powers that way, but if you don't, you have an option. That's the method that we used before. We change it to exponential form. If it's a non-calculator question, you're always going to be able to get the bases the same. If you can't get the bases the same, they're going to put it on the calculator part of your test. Okay? So there's part A. Part B. That's fancy. Again, part B, I'm going to look at, can I write this as a single logarithm? So I'm going to have log 4 of 6 squared minus log 4 of 3 cubed plus log 4 of 12. Again, with more than one adding and subtracting, the adding ones, the 6 squared and the 12, will be in your numerator, and the dividing one, 3 cubed, will be in your denominator. Okay? Break these up into factors. 6 squared is 6 times 6, which is 3 times 2 times 3 times 2, and 12 is 3 times 4. You okay with that? I'll put these in brackets so you can still see the 6, and the 12. 3 cubed is 3 times 3 times 3. We're multiplying. Any factor is the same. Yes, 3 and 3, 3 and 3, 3 and 3. What are we left with inside? 2 times 2 times 4, which is 16. Mental math-wise, this one's a lot easier. You say to yourself, log 4 of 16 is solving for an exponent. 4 to what exponent would be 16? That one you probably can say, yes, I can do that one directly. And we get 2. All right, last question for practice. Question number 13.